Hello, and welcome to our presentation on artificial intelligence applied to dairy cattle anomalies detection, a systematic review. I am Guilherme, and I'm going to be your host for today's presentation. In dairy farming, an extremely complex activity, there are numerous variables that can positively or negatively influence the production results of a property. So I'll show you next the most common obstacles on that context. Mastitis. There are two types of mastitis, clinical and subclinical. Clinical mastitis is when the signs of inflammation are evident, and subclinical mastitis if the inflammatory process requires field tests such as CMT or California mastitis test, or laboratory tests such as somatic cell count, SCC for short, in order to make its diagnosis. So thermal stress is one of the most common obstacles that we have as a hot country. We are from Brazil, and this is a recurrent problem in our livestocks. So, defined as the sum of external forces acting on an animal, causing an increase in body temperature, evoking a physiological response. This body temperature can be raised by external factors or internal factors. External factors such as hot weather or poorly ventilated areas, and internal factors are triggered by high metabolic heat due to high feed intake. Another problem that is pretty common is lameness. Lameness includes any abnormality that causes a cow to change the way it walks by affecting the legs and joints, being caused by diseases, handling, or environmental factors. So we have those problems, and they are pretty common. There are many others that we will discuss throughout this presentation, but the question here is, how do we as researchers could detect those problems that we call anomalies? We will uh, we will touch that subject more clearly. What is an anomaly? What we define as anomaly for this presentation and for this study. How do we as researchers could detect those problems or anomalies in dairy farming context using one of the most innovative techniques that exist today? How do we do that? So, we did a systematic review. We will show how we planned and organized. This question we'll be answering throughout this analysis. In order to answer this, we need data. So there we have it. Systematic review will show us all the data that is pretty much important. And we made sure to exclude any other kind of studies that don't belong in this context. Okay. So we start by defining the research questions, what we really want for this study to happen, and then we select the papers next. The primary question is which machine learning techniques and methods were employed to recognize specific anomalies in dairy cattle. So what we are trying to aim for here, we are trying to show researchers the best methods and machine learning techniques in order to solve to recognize rather, specific anomalies in dairy cattle. And then the secondary question or complementary questions, what is the accuracy of each machine learning technique when detecting anomalies in dairy cattle? So it is necessary not only to show which kinds of machine learning are detecting certain anomalies, but also their accuracy. If the accuracy is not on par with your work or some kind of project that you are trying to create, you can enhance them. You can just go to the paper and read them, basically. So, what is anomaly detection? We saw anomaly and we need to detect them with machine learning techniques. What is this term? So, let's dissect this into two words. The term detection is applied when a personalized and non-invasive neural network model combined to a database is capable of interpreting existing patterns. One example can be stress detection using a database to identify stationary heat behaviors through TensorFlow Object Detection API. So what does that mean? For a detection to be successful, it needs a method that doesn't get in the way of the production, basically. The cow don't need to know that necessarily you are there observing them because it can lead to some problems in the production. So we go to the next term, anomaly. It can be defined as an abnormal behavior characterized by lethargic state. What is a lethargic state? It is a state during which the animal reduces its activity. It sleeps more at times when it is normally awake, reduces its feed and water intake, or interacts less with its environment. Okay, so that is anomaly detection. So in our project, we need to separate which kind of articles are going to be included and articles that are going to be excluded from our research. So our exclusion criteria is that the paper or the article does not use machine learning techniques. It focuses only in a biological study, does not focus on anomaly detection, uses methods of detecting anomalies but not in dairy cattle. So if the article is characterized on one of these criteria, it is excluded from our research. And the inclusion criterion is the paper focuses on anomaly detection in dairy cattle using machine learning. Simple as that. How we can summarize the selection process. We used the platform called Parsifal so that we can sort those articles using previously explained criteria and a search string. So those search strings are words, specific words that we need to find based on those criteria that we discussed previously. And we searched with the same string for many databases like ACM, Elsevier, Google Scholar, and others. You can see right there on the left. So we go to those databases and search for the same words. And then we have phase one, that is the searching for relevant studies throughout the databases. We have 1.4 thousand of articles found on those in this phase. Phase 2 is the study classification after the title and abstract analysis. So that's where Parsifal comes in. We have all the papers in Parsifal and we need to just select the papers based on their title and abstract. We read the title and abstract and then select. The ones that doesn't fit on the criteria are discarded or rejected. And then we proceed to phase 3, the study's classification after complete analysis. So then we read all of the papers so in their entirety and see if they fit right into our criteria. We had 94 papers accepted in this phase. It is important to say that in the right there are papers that are considered duplicate. That is because we considered two kinds of studies that take place in one article. They are considered two. So if one article tries to detect two anomalies, they are considered two papers. That on the right side. Okay, that's why here we have 94 papers accepted and 108 papers accepted here. Okay. This is on phase 3. Phase 1, we didn't know what the paper had in store for us, so we have the single paper here. There you go, an image just a little more maximized for you to see. So one thing before we proceed about detecting anomalies. When we are using AI models, including our problem that represents the detection and classification, data is essential. Okay, the data type we are looking for is called features. So features are like thermometers. They tell us what the object of study, our friend Cal, is going through. So some examples are daily mucus, motion that can be gathered through images and accelerometers, somatic cell count, and milk electrical conductivity. So the main thing about those features, they are important to characterize one kind of anomaly. So they will tell us if you use certain features, it will be better than using other ones, but we'll see that later. So we discussed earlier some examples of features. So what we had in all those articles that we gathered are that mu-cubed, motion accelerometer, motion images. Those images can be a camera taken or just a videotape, okay? Days in milk, lactation, feeding and drinking behavior. Those are the most prevalent features that we have in all articles that we gathered. Now remember those research questions that we defined earlier. So you're going to show our answers and some results. So the first research question for you that doesn't remember, which machine learning techniques and methods were employed to recognize specific anomalies in dairy cattle? We have three types of models here, AI models: supervised training with unsupervised feature extraction, and unsupervised. For supervised models, we have 93% of those, and the others are respectively 1.59% and 4.76%. Researchers have a preference of using supervised models. So what is our take on that? We need to diversify more, to explore new models. We have so much more supervised models rather than unsupervised ones. So we need to try to research that. So before we show you which machine learning techniques were employed to recognize specific anomalies in dairy cattle, it is important to say that each of those anomalies, they have a mean accuracy, the accuracy that is reached by the sum of all accuracies of that specific anomaly and dividing by the number of papers. So we get that. We can see here that uterine diseases are pretty much recognizable. General cattle diseases are recognizable. Estrus is recognizable, 89% of recognition. But postpartum diseases, fertility, dystoxia, locomotor diseases are pretty much low compared to the most detectable anomalies. So there are opportunities for researchers to go after those anomalies. Okay, the AI techniques used to recognize specific anomalies were k-means, genetic algorithms, YOLO, long short-term memory. So we have here some techniques that their mean of all those articles that have those techniques implemented are over 80% of accuracy. Okay, any of those can solve your problem for a specific anomaly, and we will show those relations of which technique we use for each anomaly at the end of this presentation. Now onwards to research question number 2. what is the accuracy of each machine learning techniques when detecting anomalies in their ICAO. So in order for not to be so much convoluted on your screen, we had a mean accuracy for all the techniques that are present on those articles. So in this table, it doesn't show us the truth at all in the case of detecting anomalies because just shows it shows that some some applications, some techniques are well applied to the problems they are solving. So some examples of that is that K-means achieved great detection accuracy for mastitis. When using genetic algorithms, they were able to detect pathogens, and when using YOLO, they excelled at heat stress detection. So in conclusion, I promised you the table that showed the direct relationship of the AI techniques to the anomalies that were used on those papers. Those tables are what we intend to show our scientific community is we have some anomalies that work well with some AI techniques and some features that are able to detect better some kind of anomalies. And those tables just summarized all of those articles that we. So those tables are we intended for you to use it as the first steps for you to immerse yourself in this kind of problem. Where do I start? Which AI techniques do I use? If you want to research it, you can mix and match any kind of AI techniques to anomalies and features and see here which turns out okay or which doesn't. And so if you want to solve problems, that those tables are for you too, for use. You can see which AI techniques mix well with some anomaly that you want to be detected and which features are you aiming for when you're in local, right? And so that's that. So thank you for your presence here at this conference. If you have any questions, please address those to our comment sections on YouTube. So again, thank you. Okay? And special thanks for all you people that made this presentation possible. Instituto Federal de Goiás, we thank you. American CSE and all of the staff that is present and made this congress possible. Thank you. And the templates is provided by PowerPointify. Thank you all.